Time to move on to the next step, something called permutations. Well, we did FCP, fundamental counting principle. How is permutations any different? Well, in permutations, the arrangements of the objects, the order matters. What do you mean? What are you talking about? Well, think about your combination log. It actually shouldn't be called a combination log. It should be called a permutation log, because you know if your combination, let's say, is, oh, let's say 20-35-4. Let's say that's your combination. I would howl laughing right now if that was your actual combination. But anyways, let's say it's 20-35-4. Doesn't the order matter? Doesn't the order mean something? That means that there's only one way. If you knew the three numbers, there's only one way of opening up your combination log. You have to do it in order, 20, 35, or 4. Because if you put down 35, 24, that could be somebody else's combination. That could be somebody's completely different combination. Or you could put down maybe something like 4, 20, and 35. And you can keep on going until you exhaust all the possible arrangements for that. So in other words, these are three different permutations, meaning they can have three different locks on your locker, right? See how it works? So the order is very, very, very important here. Okay, so let's take a look at a few things before we start going crazy on permutations here. One of them is this. Da, 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 a permutation definition. Okay, a permutation of n different objects taken n at a time. What does that mean? Well, look at the word hockey. Notice no repeats. I'm not saying 8 should go first or anything, so no conditions, no nothing. Using the fundamental counting principle, okay, we have 1, 2, 3, 4, 5, 6 letters, right? Hockey, 6 letters. So if you do this, 1, 2, 3, 4, 5, 6 letters. 6 spots, 6 letters. First choice, you got 6 choices for the first one, 5 choices for the next one, 4 choices for the next one, 3 choices, 2 choices, 1 choice. And if you think about it, the word hockey, if you want to get the word hockey back, order matters, because if you scramble this, the order is completely different, makes a completely different word, maybe even a nonsense word. You know what I mean? Okay, so here we go. Think about this now. The number of permutations, which we call arrangements, of n different objects taken n at a time is called factorial. Because in the old days, you'd go 6 times 5 times 4 times 3 times 2 times 1, and you'd throw it in your calculator and you'd get something that looks like this. 6 times 5 times 4 times 3 times 2 times 1, and you'd get a number that looked like that, 720. There's got to be an easier way of doing this. Of course there are. It's something called 6 factorial. And factorial, you just put an exclamation mark. That exclamation mark means that you're going to do a countdown. 6, 5, 4, 3, 2, 1, and you're going to multiply them all together. Well, that's got to be on the calculator somewhere. Well, yes, in fact, it is. Now, the cool thing is if you've got the older calculator, you're going to have to do this. You're going to have to go into math. You're going to zip over to something called probability here, and sure enough, look, there it is, number 4. There's the factorial. Okay, so if you hit 4, boom. Well, wait a second. That's going to take the answer of 720 and factorial it. Oh, that's not what we want. We want 6 factorial. So I got to go back into math. I got to mouse over to probability again, all the way down to 4, and there's my 6 factorial, which gives me 720. Oh, that's a lot more convenient than going 6 times 5 times 4 times 3 times 2 times 1, right? It's just that factorial button is so much nicer. But what if I've got the nice TI-84s, those ones that you spent a whole bunch of money on, a brand new calculator? Is there an easier way? Yes. As a matter of fact, you'll hit alpha, and I believe it's F2. Yes, it is. It is F2. Look what happens all the way down here. There it is. And it even shows you that, in fact, it is a factorial notation. Whatever the number is, factorial. And the nice thing about using that is, check this out. I didn't put a 6 in yet. I could just delete this part, right? And I can put my 6 in. There's my 6, go alpha 2, there's my 9, there's my factorial, and I get the same result. So again, it depends on what kind of calculator you have. Do you have the newer one? Well, then you can go alpha F2 and you've got it. Okay? If you've got the older one, then you have to hit the math and probability one. Okay? That'll help you. So let's get some practice doing this then. Okay. So here's the definition of factorial. Factorial says any positive integer, n, the product of all the positive integers up to and including n. So you basically just do a countdown. 4 factorial, 4, 3, 2, 1, multiply it. But here's something that's really, really, really important. What if I have a 0 factorial? Surprisingly enough, 0 factorial is actually defined as 1, not 0. This becomes incredibly important a little bit later on. So I'll make reference to that later. Okay, so look at this. All of these questions can be written in factorial notation. So look, determine the number of permutation of each of the letters of each word. Okay, let's look at the word angle. No repeats, no conditions. 1, 2, 3, 4, 5. So in fact, this is 5 factorial because you know 1, 2, 3, 4, 5. 5 choices for the first one, 4 for the next, 3, 2, and 1. And again, you can throw this in your calculator if you want. It's 5, 4, 3, 2, 1. Or you can just go over and just do the factorial thing. And that factorial thing is so much easier. So here we go. 5 and factorial. Alpha 2. There it is. Position 9. There's 5 factorial. Punch it. 120. Makes sense, doesn't it? Okay. So you put down, 5 factorial. It's 120. Look at the word Kelowna. Okay. 1, 2, 3, 4, 5, 6, 7. Arrangements of that. Again, if you want to put that down as fundamental counting principle, you can. So that's 1, 2, 3, 4, 5, 6. You'd have to have one more space. 7, 6, 5, 4. Oh my goodness, that's just a waste of time. Now you know factorial notation. 7 factorial, that's easy. Go into your calculator, boom. Let's do this for those people who don't have the new calculator. Math moves over to probability, and it's number 4. There it is. This works out to be 5,040. Okay, 5,040 arrangements. That's how factorial works. That's how your calculator works in this particular situation. So the next thing we're going to do is play around with this idea of factorial notation, and let's see where that takes us. Woo! Stay tuned.